So for the quiz, we have here what type of circuit? Parallel circuit, yes. And then this one? Series. And then what's the characteristics when it comes to voltages? Which one has the same voltage across each component? Parallel. And then the sum would be series. And then here, sorry, let me see. Yeah. Yep, that's right. And then the current. Yep. This would be current now. Okay, Ohm law. V equals IR. So I being current. So I times R. All right. So that's it. So if we were to take V equals IR, this one's this one's a little bit more tricky because it's different resistances. Okay, never mind. There is other law, Kirchhoff law, I think. It's 1 over R, but we're not going to talk about that, so that's okay. All right, so we got a full score. Any questions on the quiz? All right, we're going to continue on with batteries here. So what do you recall from last week? They're heavy?
Yeah, you need a lot.
Yeah, actually, these batteries are lighter than other chemistry types. So if you're in a normal internal combustion engine car, you have a lead acid battery, right? That's what you use to help start the engine. That's actually much heavier, or per energy output, or what we call a low energy density. Yeah, so for the same weight, you get less energy. So lithium-ion batteries are actually pretty high energy density, which is good when you are putting it in something that flies, because every weight counts on a flying machine. So that's why we use lithium-ion batteries instead of things like lead-acid batteries, because the energy density is much higher. Density, if you might know from physics or chemistry, that's the amount of weight per volume. So when you have the same volume but less weight, that would be less dense. You might actually know also from taking part 107, right? You heard of what they call it, altitude density. So the air is less dense as you go higher up, right? There's actually, if anyone knows how much weight of air is on us at sea level, we don't feel it, but there is literally a column of air like on us. Yeah.
1 Newton.
It's
1 bar. 1 G.
well, give me like in terms of, let's say, pounds. Like
14.
Yeah, it's like 14 something pounds. I forgot. Weight of air at sea level. Yeah, 14.7 pounds per square inch. Per square inch, there's 14.7 pounds. So you're stronger than you think. You're constantly carrying this air around. But that's at sea level. So as you go higher up, you have less air on top of you, and that's why the density is lower. It's the same reason at Denver Airport, they have a very long runway because it takes a while for you to generate lift. It's also why during the summer, sometimes, I don't know if you ever encountered, but like John Wayne here is actually a pretty short runway. It's a very short runway.
A lot of rules.
Yeah. So there's also rules in terms of all the rich people in Newport Beach, limiting when you can fly and stuff, but that's a different thing. Yeah, it's only from 7 to 11, 7 a.m. to 11 a.m. So you see all the planes queue up at 7 a.m. and then they just take off one after another because they're not supposed to take off before 7. But it's a pretty short runway. So actually during the summer, when the air is very hot, it's what, less or more dense?
Less.
It's less dense, okay? The planes can't generate enough lift, so sometimes they may actually ask you, hey, we need some volunteers to take the next flight because it's too heavy. It's too heavy to take off on that short runway. So it's the same effect having hot air versus high altitude air. But anyways, that's density. Okay, so planes like drones need a dense enough air to generate lift. So actually, I don't know if you'll notice that much, but drones aren't gonna last as long in the air as in the summer versus like a hot summer day versus the winter. Do you notice on your bigger drones or no? I think it's
for the certain amount of minutes.
Yeah.
We never like had to fly along, you know what I mean, along.
Yeah.
To try that.
I think it's because the impact on a percentage level is small enough where our drones are only flying like 20 something minutes. It may be like a minute less of flight at most, something like that. That's why we may not notice it, but like on a longer flight, you'll notice.
Is that true even in the extreme cold?
I think there is a certain point where you get too much.
Flying
Yeah, well then that actually comes to a different issue. The battery,
yeah, the
the batteries can't is
Yeah,
not.
they don't-
they're
yeah,
not-
because I was flying
yeah.
in Washington over the
Yeah,
break. and
right.
It got down to,
Yeah,
it said you could fly up to, a certain level.
right.
But it was like, I'd go up, and it was like the battery would like.
Yeah, so that's a different issue from like fluid dynamics. That now comes down to the limitation of a battery chemistry. It can't perform at really low temperatures. The power output has now reduced. Yeah, versus like when it comes to efficiency, it's still actually more ideal to fly on a colder day. But yeah, I know certain batteries, I think maybe the Inspires and Matrice, they have self-heating function in the battery. So that's helped mitigate that if you're trying to fly in a cold environment. Yeah, so the limitation comes not from the air density, but rather from the battery chemistry. Yeah. So let's say you had a gas power drone, then it wouldn't be an issue. It would benefit from the colder temperature. Yeah. Okay, so I don't know how we got into density, but
LIFO being efficient.
yes, that's right, energy density, that's right. Okay, so some terminology we talked about last week. Here, let me pull up the notes here. Oops, quick time. Okay. Oh. All right, so some terminologies we talked about. Voltages, right? Voltage at this point you should be familiar with. What is the nominal voltage when it comes to a battery?
3.7.
Yeah, that's what it's rated at. Okay, 3.7. Right here on the right side, you see 3.7. So we'll see it listed on the battery. I'll have everyone take a look at this later, but right now I'm just gonna pull up one battery. I think I pulled one. Okay, I remember. I pulled one from the box, but we actually have a bunch back here. So you'll see a total voltage. Like the battery that we looked at here was 14.8 volts. Okay, but then you have to divide by the number of cells to know what the individual cell voltage is. So we had 4 cells because it was listed as 4S on the battery. Do you remember what the S means? Yeah, the batteries are connected in series, which, as you know already, means that the voltage is the same or added up. Yeah, they're added up, okay? So you can see when we did 14.8 divided by 4, we found that each cell was 3.7 volts, all right? And that applied to another battery that we found, which had different numbers of cells, but when you divide the total by the number, you still get 3.7. Now, there's a range when it comes to actually what the actual voltage on the drone battery can be. So it can range anywhere from a maximum of like 4.2 volts when it's charged, and it can go down to like 3.2. So that's kind of the range that you're going to see. 3.7 is coincidentally like right in between, in the middle. around the 50% mark. So last time we took a multimeter, we measured, we found that it was on a 4S battery, it was almost 16.8 volts. I think it was like 16.2 or something like that. So you can see right here, it's like the 16.2 was like right here. So it was very close to 100%, and that's why we said it was like 95% or so. Okay. Great. Any questions? Voltages, cells? Yeah? Did you? No?
Charging.
Mm-hmm.
The example you gave earlier of a battery in a car.
Yes.
You would normally take the red and put it on the positive, take the black and put it on the negative.
Oh, okay.
All right? For charging.
Okay.
What does that do? Does that send current backward or does it send current forward?
Are you saying
Are
you're
you
going to
trying-
directly charge a battery to
Yes. If you're charging
Oh.
a battery, are you pushing voltage into it or are you pulling voltage out of it? Because you've got
Mhm.
positive and negative,
Yeah.
the current has to flow one way.
Yeah, yeah.
So which way does it flow?
Well, I wouldn't put a battery straight to your car battery if that's what you were trying to do.
No, a charger.
Oh, to a
You put
charger.
charger right on the
Oh,
back.
okay.
You
Well,
would put the positive on one side, the negative
Yeah.
on the other.
yeah, I'll demonstrate that here. Well, this has to overpower. This has to provide the current to go. To go into the battery. Yeah, so the charger would charge the battery. I don't know. Sorry.
Well, I'm just trying to figure out which direction is the current going. You've got
Oh, into the battery. Yeah.
But you
Sorry.
said it goes negative to positive, you're wondering if it goes the opposite, positive, yeah.
Right. I mean, how does it get the current back into the battery?
It flows it through the. It should flow it through.
I guess it's a circuit, so it just. it
Right.
goes-
Oh, okay. I'm trying to
Is it
see if you're doing
with the
backwards.
circuit or is
Yeah.
it against the circuit?
Yeah. Yeah. Actually, I don't know.
Now, when you bypass the battery, what you're trying to do
Yeah,
is
yeah,
you're
yeah.
trying to get the electrons back.
Right. You're trying to get all the electrons back in. So.
to the lead plates.
So
of
you're.
the acid.
I get what you're saying. You're saying when you charge it, it flows backwards.
Well, I don't know.
Okay.
I'm just-
Actually, I don't know either. So let me see. Yeah. Okay. Let me look it up. Battery does current flow backwards? Yeah. Let me see here. Okay. So it looks like it flows backwards relative to when the battery is powering a device. That's what it says here. Yeah. So yeah, you're reversing the flow. That's what it seems like. Which makes sense, I guess. Yeah, it's trying to like.
Is that the same for the lipos? It works the same way?
I think so. Yeah, it should work the same way. I mean, I'll just type in this one, lipo. It should work the same way. Okay, never mind. I'm gonna wait till John shows up because like he's the electrical engineer. Like I think he might be. Maybe he knows a little bit more. But let me see why though. Instead. And charging flow from positives and
Importance of correct polarity is the last line.
mm-hmm. I'm gonna have to look into that. I'm not exactly sure. Let me write that down. Look at it during the break. I'm still learning to this day. Okay, so I'll look into it. Let me see what happens. All right. Okay. After the break, I'll find out what the answer to that is. Okay, so let me show you. No, well, there's a trade-off. I think we should get started with building the drone. Yeah, that way we can solder. I can always leave like the last 30 minutes of class if you want to practice soldering, but I think we should keep going on with building the drone. All right. So so here's some of the letterings you're going to see. We already saw S. We're going to talk about C rating, storage capacity, charging. Okay, voltage as a review. So I'll say more like this to make it simple. I like to keep it easier to remember. 4.2 is your fully charged. We're going to store the battery. That meaning when you're not using the battery for more than a week is kind of what I say. Try to store it at about 60%. Okay, that's why I said 3.8 because 3.7 is about 50%, so 3.8. I have my drone usually warm me at around 30% just for safety and plenty of buffer. So that's about 3.5 volts per cell, and then the drone on the ground at the 3.2, which is like still, I think it's still like 15% or so, or maybe even less. I like to actually land even earlier than that. I just say 3.2 just to make it an even number between 4.2. It's just a difference of 1. I just say 3.2. But generally, I like to land a little earlier than that. 3.0 is the absolute minimum. Really, you should never reach this point. This is not good for the drone battery. And if you look at the pile, like I mentioned last time, those batteries, at least one cell has dropped below 3.0. Even if you have the rest fine, if one drops below a certain point, the DJI software says, nope, we're not going to use this battery anymore, and shut the whole thing. It prevents you from using it. So there's a LiPo voltage curve. Let me show you. So this is a LiPo voltage curve, and this kind of shows you how the voltage drops with certain percentage of charge. Okay, so in the beginning, you start off, well, here it shows a little more than 4.2, but we'll just say 4.2 for general approximation. And it drops pretty quickly in the first like 90%. And it stays pretty steady. Actually, this curve is not the best. I wouldn't call it like flatlined, but it's going to like more gradually decline. But then you see after 20% is where it starts to go off a cliff. You see, that's where 3.0 is really dangerous. Really, you should be stopping a little earlier than that, because every like 0.1 voltage after that continues to drop drastically. And this is like what happens if you let the battery sit too long. It falls off the cliff, and then you can't revive the battery. We already lost actually 2 or 3 batteries from the drones last year, just from the FPV kits, because people let it sit plugged into the drone. And these are not DJI batteries. They're not smart. They're going to just keep pulling from the battery. The battery's not going to shut itself off. So it's very important that we be monitoring these batteries while we're using them. And there's ways to monitor it, okay? Even though we don't have like a meter on here, you can get a meter like this one, and then you can keep reading the voltage as you're using it. And then there's other meters that will actually send an alarm, an audible alarm, if any of the cells drop below a certain threshold. That way you don't keep it plugged in and keep draining the battery. So we lost a couple batteries that way. Let's not lose any this semester. And that's just keeping an eye on the voltage. Okay, so this is the curve here. You can see it's not linear. It's like it's like a sideways S curve. Okay, so this is the part right here, the 10% below that we have to be very careful about. Okay, so with these voltages, or these batteries right here, we have a 3 series, 1 parallel. Or in other words, just a 3 series cells. So it's going to be, the first number I listed here is a nominal. That's what we named it at. And I'll just say 3.7 volts. and then the peak voltage is going to be, do you remember? 4.2 volts. So again, if we do 3 times 3.7, we get 11.1. Okay, let me do that. Sometimes, the reason I had different numbers is sometimes manufacturers use 3.8 as the nominal, and that's where it's like kind of, it's not standardized. It's either 3.7 or 3.8, but since I kind of started off with 3.7, we'll just keep using 3.7. So 14.8 for this one, 14.8. So if you ever read a battery and you get a slightly different number, calculate it out. More than likely, it's going to end up being like 3.8 or sometimes 3.75. But it's going to be between 3.7 and 3.8. So just, they may not line up exactly like what you see here. But that's kind of the point I'm trying to make here. Is last semester I used 3.8 because the battery I picked up must have just been a 3.8 as the baseline. But 4.2 is basically the same for all of them. So if we do 4.2 times 3, that's 12.6 volts, times 4, 16.8, times 6, 25.2. You notice I actually skipped 5S. Has anyone seen a 5S battery? I actually personally haven't. I don't know why, but they go like, you'll see a lot of 1S, 2S, 3S, 4S, and then 6S. I don't know why 5S is just not really used. So that's why I skipped it, because it's not a very common thing to see. They exist. It's just that maybe in the drone world, we don't really use 5S that much. So it's just kind of an interesting observation. Okay, now C rating. Actually, I'm just going to pass, well, here, grab a battery and pass it down. That way you can all look at this. Well, you can follow along while we take a look at, while I explain everything. Okay. All right, go ahead. Look at the drone, or look at the battery here. And we'll start off by going over what we already know. So, what are some things that you see on here? What are some numbers that you see?
95C.
Okay, I'm gonna write down this battery. This battery is the R-line battery. Okay, I heard 95C. What else do we have here? 550 milliamp hours. Okay. What else? I see, wait, sorry.
8.14.
I see 4 cells. I see the word 4 cells. I see 14.8 volts. And I see 8.14 watt hours. Anything else on here number-wise? Oh, look, it even has instructions on the back, which will be perfect as we go over it. Okay, these are the, like, in terms of the specifications, this is what we need. Okay, so what do we know? Let's work with what we know. What do you do know? Let's talk about those. Okay, so this, it doesn't say 4S, but because this is actually clear. Oh, the box says 4S?
Yeah.
Okay. Oh, good.
4S1P.
Okay, good.
4 cells.
We're lucky that our box we have the box, but we may not have the box, which in that case we can still come to the same conclusion. But since we have the box, good. Now, it's 4S1P. If you didn't have the box, how else would you know?
Right here.
Yes.
You can see the 4.
You can see the 4 cells. Now, you may not know, maybe they are 2 stacked set next to each other because this thing covers it. So you may not know by looking at that. But more than likely, yeah, it's just going to be. Usually you could tell if it's going to be parallel because it's going to be much wider. Like, the cell's like a stick of bubble gum. So that's why, like, you're not going to find something even thinner than that. So if you find something thicker, then possibly. But just because it's thicker, double the width, a cell can also be that big. There is no standard
The
cell.
wires, maybe, the black wires?
The wires won't tell you if it's parallel. It'll tell you the S, it won't tell you the P, I guess is what I'm trying to say.
Well, this says one
Right.
P, so where's that one P at?
Well, 1P is because there's only one set of these. If you had another set parallel to it and they're all like tied parallel, that would be the 2P. But that's where you can't really tell the P. You can always tell the S multiple ways. You can look at the number of cells. What do you see? This happens to be clear. Not all of them are clear. This one has to be clear. There's another way to tell, which is actually the number of wires on this thing. What were we gonna say?
If you knew it was 14,
Yeah?
14 volts, you divide that by
That's right.
7, it'd be 4.
That's right. So look at these two right here. We have 14.8 volts. 14.8 volts divided by 4 cells is what? Is it 3.7? Okay. So that also confirms that we do indeed have a 4S battery because 3.7 is our nominal.
If you didn't know the cells, if you just divided by 3.7, that would give you the cell.
That is true, actually. That's right. If you didn't have the cells, let's just say you had 14.8 volts. Okay, you could divide by what we know to be a nominal 3.7 volt, and then that would give you 4. That gives you a number of cells. So, very good. That's another way to tell. So what I was trying to say earlier is you won't be able to tell this, though, the 1P. You won't be able to tell just by looking at it. But more than likely it is a 1P. I don't really come across too many 2Ps or even higher. So just because the size of the batteries we're working with, there's no need for you to do a 2P. You just make a bigger cell. So that's what I was mentioning earlier. There's no standardized cell size. So this cell happens to be the width of a bubblegum stick, but it could be wider than that, and it's still considered one cell.
And it would still have the 3.7 volts?
Yes, yes. Each cell is always going to be 3.7 volts. Yes, so important to remember, cell sizes come in different shapes and sizes. There's no standardization when it comes to that. So the only true way to know is to open it up. You can open it up and then you can look, okay, it's one cell. There's not 2 underneath here. Okay, great. So that's how you tell. There's another way to tell by looking at these, what we call balance leads, and I'll go over that later. But the short answer is the number of wires you count here minus 1 is the number of cells. So how many wires do you count here?
5 minus 1.
5 minus 1 is 4. Yeah, I'll explain why it's a minus 1. Or you can think about it first. Think about why it might be.
One is a single lead, and the other are 4 individuals from the battery.
No, not exactly. Yeah, they're all connected to the battery. If you draw it out, you might actually figure it out. They are all connected to the battery. Yes.
To balance it when you're charging it?
This is a balance. Yeah, this is called a balance plug. So that means each of these are plugged into each cell. Yeah. But if you draw it out, I think you'll actually figure out why it's always 1 extra more than the number of cells.
One is common.
No, not exactly. Yeah. I'll show you later. I just want to present that challenge if you want to figure it out. Okay. What else do we know from here? Does this look familiar right here, this thing? Yeah, milliamp hour. What is that? Or maybe I should start with this one. This one's maybe more common. We don't see that one. The other. Watt hour. What is watts? What's a unit of watt for? Power. P equals, okay, so then this is power times time equals what?
Voltage and current. Voltage times current.
No. Do you remember? We didn't touch about it too much, but I did talk about it. This is what the electric company charges you. It's energy. So energy is power times time. You'll see it as as kilowatt hours. That's typically what they'll charge you at. So what is power? You were saying it earlier. Power.
Voltage times amps.
Yeah, that's right. Times times current times time. That's energy. Okay. So the current, okay, we'll just stop there because we need to talk about current. All right, this is the one I want to focus on right here. This 95C. 95C, that is related to the amount of current the battery can provide. All right. So current, if you recall, is how much electrons flow through a given point. So it's like having a wider river versus a narrow river. You have more water that can flow through a bigger pipe versus a smaller pipe. You still have the same water pressure, but just more water, or in our case, electrons can flow through. So in general, the more powerful your device, the more current it needs. So like you trying to use a cell phone charger is very low current compared to an air fryer or a microwave. Those use a lot more current. Okay, we have, depending on your drone, the size, the bigger the drone, it's going to use more current, and also the flight style. An FPV is going to use more current because the way it flies, it's much more aggressive, and it's going to need a lot of power to make it go flip and all sorts of acrobatic movements. Okay, so that's why we have to look at this current number. So what you see here is going to be listed as C. So C is for current, not for cells. So that's probably why they use S to designate the number of cells in series, because C is already it'll be a conflict with current. So that's why C is for current here. And this number that you see here, it's going to typically be rated as the continuous current. So sometimes your battery might list two C numbers. So the continuous is how much, with the maximum it could provide continuously. And in this case, what do you see here? 95C. Now 95C does not equal 95 amps though. The C is a variable and it depends on the capacity of the battery. Okay, so I want to clarify that point. If you do see another number, let's say for example, we see 95C / 140C. This 140C is going to be your burst or peak current. So if you do a flip all of a sudden, it could provide that extra boost, but only for a short period of time. Like if you had a nitro on a car or something like that. It can only do it for a short period of time. So that's going to be the peak current. Okay, so how do we calculate what C is? I was saying it's a variable. C is going to be basically 1 amp hour. So how many amp hours do we have on this drone, or on this battery? Amp hours. 550 is going to be milliamp hours. So we need to convert this to amp hours. So how many milliamp hours do we have in an amp hour? Yep, that's right. It's going to be 0.55 amp hours is equal to 1 C. So 1 C is 0.55 amp hours. Now, if we take this thing, here, let me do this. 0.55 amp hours is equal to 1 C, okay? Now we had 95C. 95C, and we take our conversion now that we just generated. What is, let me do this. Okay. I'm just going to drop the hour, and I'm just going to say 0.55 amps per 1 C. So we have 95C listed on here. What is that in terms of amps? 52.
0.25.
Okay. That is 1C. This is 1C here. So that's how much continuous current you can draw from this battery. 52.25 amps ish. All right. It's a battery after all, so it's not going to stop exactly at 52.25, but it's going to be around there, pretty close. All right. So that's C. Let me see if I have an example here. Okay. Let's look at our examples here. If we had a 1500 milliamp hour battery, what's 1C? Yes. So once again, we convert this into amp hours. 1.5 amp hours. That means, here, I'm just going to complete this, equals 1C. So that means 1.5 amps equals 1C. If we had the same battery here listed at 95C, what is that in terms of actual amps? Yeah, so what is that? Can anyone calculate? Should be 140, right?
142.5.
Huh?
142.5.
142.5. Okay, so that's how much amps. You can see as the capacity increase, the number of amps you can use increases as well.
So all the 95C is just a percentage you can use of the amp hours. 95% of 1.5 amps. It's 142.5. So it's just a percentage.
It's percentage?
Same
Yeah,
percentage.
I guess that's another way to put it. Yeah, but
That's
sometimes,
easy for me to remember.
sure. Yeah, sometimes the percentage, yeah, you can think of it as a percentage. Actually, I never thought about it that way. So yeah, you could do yeah, so if you had 100C, then that would just be basically, you just drop one of the zeros. Yeah. Yep. Yeah, okay. Yeah, that might be a better way to remember it. Okay, well, we can apply that to the next example. The next example is 650 milliamp hour battery. Okay, so here, I'm just going to say example 1, example 2, example 3. Okay, so if we had a 650 milliamp battery, which is the same as 0.65 amp hours, okay, and then you take your percentage, which is 95. So what's 95% of 0.65?
61.75.
Huh? 61.75. Okay. Yeah, that might actually be faster. Oh, let me just complete this by putting in the, we want the, what's it called? Times 95, right? Because it's the percentage. Maybe I'll write it like this, 95%. Oh, okay. So you kept it in milliamp hours, right? You keep it in milliamp hours?
You can go either or and divide it.
Because 95% of 0.65 amps should be like 0.6 something, right? Oh, you just multiply by that number. Yeah.
The 95, don't make it.
Yeah, so it's not percent. It's not percent. You just multiply by that number.
Like
Yeah,
that
yeah.
95C, just
Yeah.
multiply times 95.
Yeah, yeah.
That's the way
Yeah,
I-
yeah. Okay.
Because C equals 0.65 amp.
Yep. Yeah. That's basically doing the same math. Yeah. So there you go. I mean, eventually it'll come a lot faster. So yeah, there you go. So do you get C then? If you look here, I also mentioned we want to charge batteries at 1C. So what's 1C? You already calculated previously. I will underline 1C in each of these cases. 1C, 1C, and 1C right here. So on these chargers, it's going to ask you two things. Well, it's actually going to ask you three things. What's your battery chemistry? So in our case, it's lithium. And then what is your S? It's going to be what? 4S. and then it's going to ask what current. You notice it's not going to ask what a C is because C is a variable number. So it's going to ask you at what current do you want. So if we were charging this battery, what current will we charge it at?
550. 550 milliamps?
Divided by 95.
Yeah, 550 milliamp. Now this thing is going to generally give it to you in amps. So we would do it at 0.55. Yeah. Not divided by 95. Remember, we're asking not the discharge current, but we need to charge it at 1C. So we're just finding 1C. So it's as simple as just looking at this number, and it's mostly displayed in milliamp hours, and you just move the decimal point 3 places. So it's going to be 0.55 amps. It's as simple as that, just to find 1C. Okay, so let's take a look at this charger. Let me see what the next slide is. Maybe there's something else I want to talk about. Okay, I'll just point out this charger right now. So this is one type of charger, but you know, they all work more or less the same way.
Oh, those pictures I sent you, I was paying attention, it stops at 60% or 59%.
Yeah, that makes sense. Actually, if you look at the back of this battery right now, you notice it gives you similar instructions.
You can read it.
Yep, you see right here? You see right here? It says on the second line, 1C be recommended. Never charge above, sorry, it's,
2C.
yeah, never charge about 2C. Okay, so what is 2C for this battery then? 1.1, it should be, yeah. 0.55 times 2 is 1.1 amps. Okay, look at the other line down here. It says store long term at what?
Long term at 3.8 per cell.
Yeah, that's right. So that's actually what I said earlier, right? Storage voltage is 3.8. Okay. Okay, you don't need a charge cycle this. If you're familiar with older batteries, like they have a memory effect, you're told to like discharge and charge up. But you don't have to do that with lithium-ion batteries. Just make sure that they're happy in terms of the voltage. Don't drop it too low. And also the temperature. Don't leave it in the cold or in the heat. Okay. Let's look at an example charger here. So if I unplug it,
What did you say was too low, real quick?
too low, I would say, is below 3.2 volts per cell. Okay. So the actual total voltage is going to depend per the number of cells you have. So you just have to keep that in mind. If you take a multimeter to this, it's going to tell you the total voltage, and you have to count. Okay, what's 3.2 times 4 in our case? 3.2 times 4 is 12.8. Right, so you don't want to see below 12.8. Actually, we can get a multimeter. Actually, this will tell you the voltage. I don't need a multimeter. This will tell us the voltage, so we're good. I'm going to go over this in later slides. You see there's so many different connections, but the one that we're using right here is called a, let me see if I can find the wording on here. Is it on here? Yes, it is. I know it's kind of hard to see, but do you see it? Oh, it's kind of hard to see on that screen. XT30, okay? Now, on the bigger normal size batteries, you're going to get XT60. Okay, so this is not going to fit into this. So we have an adapter right here that allows us to fit. It's fine. So you can see these adapters are what they call, in manufacturing term, poka-yoke, or it's also just mistake proof, right? You can't plug them in the wrong way. Like you try to, because if you plug them in the wrong way, it's a bad thing, right? You're gonna get sparks and such. So they actually purposely designed these. You see, it's not a perfect rectangle. There's a little taper at the end. So if I try to plug in red with black, it's not gonna work. You need to plug in red with red, and it'll fit in. So even the adapter continues that same shape. It's a lot easier to see on the bigger one right here. You can see? Okay, so if I just plug this in right here, we should actually be able to see the voltage, but we first have to select the proper chemistry. So I'm going to press battery type here, and I'm just going to cycle through. So lithium battery is our first option, which is the correct one, but I just want to show you the other ones. Next one is nickel metal hydride or nickel cadmium, lead, and then these are other settings. Okay, so basically there's like 2 different types of chemistry you can do. So we're going to do lithium. I'm going to press enter right here. Okay, and then you have different types of functions you could do. You can either charge it, you can fast charge it, which what do you think is doing?
Increasing the C.
It's increasing the C, yeah. Don't do this unless you need it fast, because the reason it says not recommended above 1C is that it's going to be harmful for your battery chemistry or for the life of the battery. So try to charge it at 1C, it'll be better. Storage is going to put it into what?
60%,
Yeah, which is what in terms of voltage per cell? It says on here. 3.8. This is actually 3.8 amps. That's a coincidence right here. But yeah, we can change the amps later, yeah. Okay, discharge is going to discharge it down. I actually don't know what this is going to discharge it down to, but probably close to like 3.3 or so voltage. Okay. And then balance. Balance is actually what we want to do. What happens is each of these batteries have individual cells, and you want these cells to be close to each other at all times in voltage. So if they're full, they should all be more or less 4.2 volts. Maybe like plus or minus 0.5 volts, something like that. You don't want to see a big swing in the values. So what happens is when you're balance charging, it's making sure that throughout the entire process, the cells stay the same voltage. So if one starts to fill up quicker, it will wait till the other ones have caught up, and then they will slowly all continue together. All right. The other type of charging, which is just called normal charge, like this, just looks at the total voltage. So it doesn't care about the individual cells. It just sees you got to, what's 4.2 times 4? 16.8. You got to 16.8 volts total charge. You must be there. So that one is going to be a little faster, but again, for the longevity and the health of the battery, you better do it on balance charge. They both charge. It's just one accounts for the different cells, the other doesn't. Mm-hmm.
Battery being used,
Yes.
does it use ballast?
No, it does not. It doesn't. When you're using the drone battery, it just pulls it from the normal. So sometimes later, when you plug it into a reader, it might show an imbalance. And generally, that's an indication that your battery is starting to age because the internal resistance is building up, and they're not going to build up at the same rate. So there's one thing you could do to try to keep them from diverging too much is to balance charge them always. And then at least you kind of make sure they're subjected to the same conditions. Yeah, because the one that has less resistance is going to charge faster. And then the deviations are going to build over time if you keep charging it a normal way without regards to the balancing. So when you're charging balance charge, you do have to plug in what we call the balance leads. You see right here. Otherwise, it's not going to work. You see right now, I just have it plugged in just to the normal power plug. If I go to balance charge, right here, okay, LiPo, I'm pressing start and it's asking LiPo, right? Yes. Then it's asking, what current do you want? What current do we want?
1C.
Which is what in amps? Because it's asking for amps.
0.55?
0.55, so let's go down. Now you notice I don't get a second decimal point. So what am I gonna do?
6.
Yeah, it's more or less, it's okay. If you go 0.6, it's not a big deal, because obviously you can see, they said, you can go up to you can go up to 2C, which is 1.2, and you're fine. So I'm gonna just do that. Once I'm ready, I'm gonna press and hold, and it's gonna battery check. It's not gonna let me though, okay? Lower cell voltage, which seems a little generic, But what it's really telling me is that I didn't plug in the balance lead, so it's not going to work. So we have all these different ports, and it depends on the number of cells you have. So how many cells do we have here? 4, so it's going to be the top left. So I'm going to plug this in. Okay.
4 plus 1 wire.
Yeah, so you can see 4 plus 1 wires. If this isn't labeled, because sometimes you'll find something like this. It gives you all of the wires in one place to save space. Then you just have to favor one end, which in our case, we have to favor the right end. This is what I mean by favor the right end. You push it all the way as far right as possible. Okay, let's see what we got here, by the way. What is 15.2 volts? What is that in terms of per cell voltage? It's a 4S. You see that? It notices it's a 4S. All right, what do we got here?
3.8.
3.8, which is what? What is that like percentage-wise ish?
60%.
Which is storage, which kind of makes sense, right? Because these are brand new, and the manufacturer put them in storage mode. It's really not a mode, it's just a percentage. That's the happy resting point percentage, okay? So that's what the manufacturer did, okay? So I'm going to press cell here. It's going to cycle through each individual cell, 3.8. Look at the deviation between each cell. This is a new battery, so the deviation should be basically non-existent. It should be very, very close. At least the first 2 decimal, if I had to guess. Okay, so we changed the 3rd decimal. Okay, once again. Okay, that one's a little bit, but still. We're still 3.8, right? That's the main idea. And even though the second one changed, it was like by 1. Okay, so when I press cell, it cycles through all of them. Okay. I don't trust this percentage because, as we know, it's like you still got more or less like 60% left. But yeah, so you can see here, that is how we check. So now we can plug this into the 4S and let's try again. So I'm going to press and hold. And it works now. So that error message, was not exactly the most descriptive of the issue. You just have to be aware balance charging requires you to plug in the balance leads. If you look here, we have some stats. So the top right corner tells us our current voltage across the cells. We just read that on the meter. So that matches up. This bottom right tells us how much milliamp hour we are basically restoring back. So this is going to climb up. This is the elapsed time, 30 seconds so far. And then this is the mode, and that's the chemistry as well as the number of cells. It will stop on its own. It'll beep at you when it's done. I'm going to just press stop, and we're going to stop it. I'm going to just show you if I unplug this balance lead, okay, and then I go into just normal charge. It'll work, okay? So it's not going to balance it though, but it is charging it. So it's not ideal. You can charge it this way and it will charge it up. My recommendation, put it into balance charge. All right, so that is charging. Now, I do want to point out something. The limitation here, okay, let me just cycle through some of these. So if you look here, I can keep pressing, oops, there's a different types of lithium. So we're using lithium polymer, so that's why it says LiPo. But lithium high voltage, lithium ion, lithium iron, yeah. Fe, iron, yeah, so there's different types. Let me see what our max amp is. I'm going to keep going up, 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 up. Let's see what we have. 6. Okay, so 6 amps. That would be what in terms of C? That means what's our max capacity that we can charge this battery at? That means 6 amps is 1 C. Yeah, that's right. 6,000 milliamp hour. Yep, that's right. Did everyone see how we got there? Like, Yeah, so remember 1C is just basically 1 amp hour. So if we have a 6 amp, that's 6 amp is 1C, so that means it's 6 amp hours, which is 6,000 milliamp hours. Okay, so that's your maximum battery that capacity that you could charge. I haven't come across anything, like at least from a normal sized drone that we're familiar with, that was that big. Otherwise, if you do have something, you're gonna have to have a bigger charger. Is your battery the bigger, right?
Yeah, man.
It's much bigger, right, in capacity? So this, your charger is much bigger than this one? Okay, yeah. I figure this one's just a more generic, general use charger, but yours is probably gonna be a lot bigger. Okay, let's look at the, let me see where I can change the, okay, there we go. I press one more time. Okay, there's, this is the highest we can go. You can see 6S, 5S, 4, 3, 2, 1. Okay. All right. Now, if you were charging at 6 amps, and it's also doing it at a 6S, let me change this back. Okay, this will be the maximum power output from the charger. Remember what power is? What's power?
Energy times time.
No,
Time.
P equals what? What's a
IV.
IV? So we have current, which is A, and voltage is 22.2. So what's power from this?
6 times 22.
Yeah, what's 6 times 22.2? 22.2, 133.2. Okay, that's how much power should be coming out, or at least per our calculations. But if you actually look here, it has a lower number. You see what it says there, 80 watts. So I don't know if it'll actually theoretically even let you up to that amount. It's gonna cut it off at 80 watts. And that's not even the limitation. We have another one, which is actually our power brick here. If you look at our power brick, what is the power output from this brick? That's our current. That's our voltage. What's our power output from this thing?
60.
Oh, I'm sorry. 60. 12 times 5 amps is 60 watts. So even though this thing says it can go up to 80, actually it can't. It's gonna stop at 60. This becomes our choke point right here. So the on-screen display says it can go up to what? We calculated like 133.2. This thing says, but in reality, we're gonna limit you to 80. But this one's like, nope, I'm gonna limit you to 60. So this becomes the choke point. So 60 is gonna be the limitation. So if you wanna get up to the 80, you need to get a bigger power brick. We should get what if we were to keep 12 volts?
81.
Yeah, so 80 divided by 12, we should have a output of like, let's just say 7 amps. Then it no longer becomes the limitation. But we got a 5 amp power brick, so this becomes our limitation. All right.
But putting that much current through the battery is going to ruin the battery. If you have that lower. If you have one of these batteries and you're trying to do this,
Yeah,
you
that's gonna be more than 1C. It's gonna be more than 2Cs. I'm just saying, like I'm trying to max out the settings on this just to show you the most power, the most power consuming setting, but in reality, right, we're using a much lower setting. What are we using? Lithium, and we are doing, we are doing way lower. So what's the power output on ours? Let's take a look. We do this. We do, was it 4S? Okay, so what's the power output on ours then? This is what we're using. 0.6 times 14.8. Oops, 0.5. Okay, so it's like 8 watts. So we're like not even close to how much this thing can put out. So yeah, we're not doing that setting, but I was just showing you like, yeah, if for instance you had a battery that was 6S and it was 6,000 milliamp hours, this would actually still charge it. It would just charge it at a lower C rating, not 1C. You would have to just probably charge it at like a 0.5C. It would just take longer. That's what it's gonna take. Yeah. So I don't think we're gonna run into limitations with our hardware setup right now, just because of the batteries that we're dealing with. Okay. So any questions on the C? What that means? All right. Another thing is energy capacity. So if you look here on the battery, we have it depicted in two different formats. We have it in milliamp hour, so that's the current over a period. That's amperage hour. That's how much continuous current per hour you can provide. Okay. And then we also have it in watt hour. So that's power, that's an energy usage. Okay, so if you look here, if you have a 5 amp battery, amp hour battery, that means you can provide 5 amps for an entire hour. That one's pretty straightforward. What if you had something that uses 10 amps? How long would the battery be able to provide 10 amps for? 30 minutes, okay? Do you need to do the math here? We can just show you. Okay, so if we had a 5 amp hour battery and we want to use it for 1 hour, okay, so that's, we are using, let me draw it as this, 5 amps per hour. That's how much it can provide. Amp hours. Okay, and then we want to use something that will draw 5 amps. Oh shoot, I need to reverse the, there it is. Okay, we want something that would draw for 5 amps. That's X. Or, yeah, there you go. X hours, okay. So then you would get 5 amp hours, sorry. Let me see here. 5 amp hours. If you're drawing 1 amp, yeah, 1 hour. I know, I'm trying to, why is it so much difficult to do it here?
Do it in minutes.
Do it in minutes? I think minutes is gonna make it more confusing, wouldn't it? I'm just trying to show that it's 1 hour here. Yeah, you see these would cancel out. You see that? If it's 5 here, let's do this other example. I think if we draw it for 10 amps, how long would it last? 5 divided by 10, which is the same as 1 over 2. Yeah, so it's gonna be 0.5 hours. Okay, so that battery is gonna only last half an hour. Now, what do we have here? What is our battery?
55?
It's 55 milliamp hours, and I'll just keep it in milliamps for now. Let's say you draw 100 milliamps continuously. How long is the battery gonna last?
55 minutes and 50 seconds.
Well, let's do this. 550 divided, oh, I don't even need to do that. 550 divided by 100 is 5.5 hours. What is that in minutes? Well, we could just keep it in hours and minutes. It's just about 5.5. It's 5.5 hours. Actually, I don't even need to convert to minutes. Do you see that? Yeah, 5.5 hours. Let's say we are doing this and we're drawing it at 95C. Uh-oh. What is it now? What's 95? We need to convert 95C to amps. So what is that? Do you remember? Maybe let's do this. If we're drawing it at 1C, how long would it last? What is 1C?
0.55.
Yes. 0.55 amps. Okay, we have a unit mismatch here.
52.25 then?
Huh?
52.25.
Hours?
Amps.
Yeah. So 1C is going to be 0.55 amps. Okay, but you see how we have milliamps at the top? I'm sorry, I kept that up. We have milliamp hours at the top and we have amps at the bottom. Let's make it a little easier on us and let's use the same units. So do you agree 550 milliamp hours is the same as 0.55 amp hours? Do you see that? Yeah? Do you need me to show you how we got there? So there is 1,000 milliamps in 1 amp. So 550 divided by 1,000, that ends up getting us 0.55. So we went from here to here like that. Okay. So what is that in terms of time? 0.55 divided by 0.55. Yeah, 1 hour. It's going to last 1 hour. Now, I was presenting the situation. What if you had the same battery? Okay, I'm going to start at this point, 0.55 amp hours, and you're running it at 95C. What's 95C in terms of amps? Yeah. Remember, 1C is going to be 0.55A. So what is that again? What's that in terms of amps? 52.25 amps. Okay. How long is that?
31 minutes.
Keep it in hours for now. I'll convert it later. Point.
52.
Okay. It's going to be 0.0105 hours. Okay, I can't really comprehend that. So how many minutes are there in an hour? 60 minutes. Okay, so then times that by 60. 60 times.
2/3 of a minute?
Yeah. It's going to be even shorter than a minute. So now we have 0.63 minutes. Let's convert that to seconds. How many seconds we have in a minute? 60. So it's basically going to be about like 40 seconds. So when you use these batteries,
Make the calculator go away so I can see the.
oh, I'm sorry. Yeah. Because I only see the iPad screen. So, so even though these are rated at 95C, you can continuously charge. You can continuously discharge it at this rate, but you can see it's not even going to last a minute. This thing is just going to go. It's going to be done. So really, when you size these batteries, you need to leave enough buffer. So if your drone really does use 52.25 amps, you might want to look into something that you can. You might want to work backwards. You want to say like, okay, I want to. Typically, these drones are going to last like FPV like 5 minutes, and then you have to find out like how big your battery needs to be. So you work the other way, and perhaps we'll do that after the break to give you some time to digest. So you can come back at 3. What is it? 3:20. 20. So 35. Does that work? 15 minutes. Okay. 35. Video on how battery charging works, which I think is better explained than if I was to do it. Do you guys want to watch it? It's 10 minutes long. Okay. All right. So let me just show you. I went through a couple, and this is the one that I thought was the best. And if you want to write it down, it's going to be branch education. How do lithium-ion batteries work? And I have to stop the recording when I play it because YouTube will take down my video otherwise. So I'm just letting you know right here, and then I'll stop the recording, and then you can look it up later. I learned that last semester due to copyright reasons. I can't record an existing YouTube video. It does get a little bit into the chemistry part, but you can kind of let that glaze over you and just listen to everything else.
So that's lithium ion, not lipo, right? But similar.
It should work the same way. In fact, batteries should all more or less work the same way here. All right, everyone good? And when you're charging it, we're basically reversing it, just like the video said. So now we're making the electrons flow back to the anode, the negative, and the current is going the opposite way. They also mentioned in the video that you don't want the anode and the cathode to touch each other. There's a barrier in between. Remember last week I mentioned if you puncture a lithium-ion battery, it can cause a fire. All right, let me see if I can pull one up.
So did Samsung or whoever was having that problem on planes and stuff, did they just not have a very good barrier, or?
I don't know the exact reason, but it has something to do with that. Basically, like, maybe the barrier wasn't very good, or there might be like a manufacturing...
It caused it to fracture?
Yeah, or there might be a manufacturing defect that allowed the two to somehow touch. The barrier might still be there, but perhaps at some point there was a section perhaps that slipped and didn't allow it to keep separated. Let's see what happens. Here, I'm just going to do puncture. Because I want to see it on purpose, because some of these might just spontaneously happen. Okay, there we go. Let's see here. So now by puncturing, they're allowing the anode cathode to touch each other.
So this is a how-to video.
Yeah. Yeah. It says don't do this, but exactly.
I forgot your address.
So yes, we are carrying around very dangerous weapons here.
Now, when I travel on an airplane,
Yeah.
they let me bring it on carry-on.
Yeah.
They don't want it underneath the
Yeah.
plane. Why is carry-on any safer than underneath the plane? Or
Well, what happens in a carry-on? Like what's in the cabin versus outside the cabin? Yeah, pressure. It's a pressurized cabin.
oh,
So,
and I don't
yeah.
throw my luggage like the.
Oh yeah, your luggage that goes underneath is not pressurized because they, it's going to cost more to pressurize areas like that they don't need to be pressurized.
So the pressure does something to the.
I don't know exactly what happens, but I believe the pressure probably just makes it more susceptible for, I don't know, like, I'll look it up, but I'm sure it has to do with that, where it's more likely to occur in a depressurized environment than it is like a normal pressure environment like where we are.
I mailed some batteries to my destination ahead of time, just
Okay.
in case they confiscated my batteries at the airline.
Oh, okay.
So I would have batteries when I arrived. Carrying my drone was okay. But it was the
Did you
battery.
mark that? Did you tell them it was actually hazardous materials?
It was on my carry-on. It was in.
Oh, okay.
It went through the scanner.
No, what you mail.
When you mail,
Mailed it, did you
Oh,
tell
I
them?
bought them, and this is the address I want them delivered.
oh, okay. Because normally, like even in the U.S., if you mail domestically, you're supposed to tell them it's lithium ion, and they'll put a label that says ground shipping only.
Oh,
For this reason.
I
Supposed to be.
It
Supposed to be.
arrived at my destination,
Okay.
and I had plenty of time to charge it and
Yeah.
do what I had to do.
Okay.
But I just didn't want any problems. Everybody keeps saying, just carry it on, you'll be fine.
Well, yes, I carry on all the
Famous
time.
last words.
I carry on all the time. It's completely fine. Yeah. Now I know EVA Airlines has now banned lithium-ion batteries. So you can see right here, actually effective this month. But EVA Airlines, they go to Taiwan, so they're a Taiwan brand. So it may not be affecting us now, but the fact that they're doing this might mean other airlines are going to follow suit soon. Okay, so they're banning power banks on board because of probably this reason. Yeah, so
Carry on or?
carry on too, just on board. Yeah, like. So let me look here. Lithium ion batteries. Why not check bag? It's the only difference I could think of is low pressure. Let me see what it has to do with it. Yeah, it says right here. Thermal runaway is basically what you saw. Yeah, it just went crazy. I guess is low pressure is not as good. Yeah, so I don't know how, but another reason I could think of is if there was a fire to break out, you wouldn't know till it's like spread like crazy. At least in the cabin, you could start seeing some smoke and you can like get a fire extinguisher and put that thing out. But like in the cabin below, like how would you know until it's like it literally has already become a huge fire underneath?
So what happened this month? They're banning all?
No, EVA Airlines. EVA Airlines has banned from you bringing like
Ireland, right?
like what?
Taiwan.
It's a Taiwan airline, so it doesn't affect you at the moment. But what I'm saying is other airlines might start doing the same thing.
Somebody started it now.
Yeah,
for others
yeah.
to follow.
Actually, Korea got a fire in the cabin.
That might have been why.
Yeah, they lost one airplane.
Okay. Yeah, because the
And
smoke.
yeah.
The smoke is also very hazardous, and you can see just from a little battery like that, you see how much fire and smoke came out. Yeah. So, yeah. So they're banning like power banks, like any spare battery. So like the instance that you're talking about, they probably won't let you do that. But if it's attached to a device, like a phone and a laptop, they're still allowing you to. Yeah. But if it's something that is separate, then no.
Yeah, I'll touch with that.
So, anyways, you can see why they're banning it, and also why they don't want you to put it in the check bags.
Yeah, so that means the drones, even drones, they want you to carry on your batteries, so.
Well, I always carry my drone just because in case they lose the bag. But technically, the drone itself is fine to just put it underneath in the
But
check
no,
bag.
the batteries-
Yeah, I always do.
So would those be denied on the plane, or is it only lithium ion?
That is lithium. It just says lithium. Yeah, it doesn't matter lithium ion, stuff like that.
What are people gonna do then?
I don't know.
Drones as a living in-
I don't know. But again, this is just
Ahead of time.
one airline, but I'm just saying like I can foresee other airlines.
That's their main airline, I think.
The Inspire 2 batteries were designed to be able to carry on
Yeah.
in the cabin,
Mhm.
not in the
Yeah.
cargo.
Yeah, this one's just banning you altogether.
Yeah.
I don't think they even allow you like even
200 milliamps. It's
Oh, it says right here. It exactly is the Air Busan. Busan is in Korea. So I think it's because they saw something happen. Yeah, so
The January.
I don't know what you do then.
It's Taiwan, is it because
I
they're
think
Chinese or?
No, it's just because they're all next to each other. Like they saw, hey, our neighbor Korea had an incident. Let's be proactive and not wait for something to happen. So they just banned it. Yeah.
Yeah, so the South Korean airlines said did it first, then EVA did it.
Yeah. Yeah.
What are those travel bags? Are those things flameproof, or are they just like?
Oh, we actually have it back.
Don't they have some of those? That's
Well,
usually-
I know,
Do
but
you think that would count, like, as long
I've
as
got
you
them,
have
but
that?
it just doesn't seem like.
So actually,
Fire.
I don't know, I've always wondered.
So here's the bags, in case you're wondering. I've actually never seen what happens if there was a fire to break out in this. I have no idea.
YouTube, get some matches.
I know. Let's look at what.
Yeah, let's go outside.
Let's see what happens. Lithium, fire in fire bag.
That doesn't seem like it would, yeah.
Oh, okay. Let's see.
I mean, high quality.
12-minute video. All right, that's too long. Yeah, I know. Let's get to the fun stuff. All right, here we go. Wait, he put a hole in it. All right. Why is it a 12-minute?
Very safe.
Well, there's a hole in it. I mean, yeah. Now it just looks like a little oven now.
Okay, there's those vent holes in action. I'm sure it's not over yet.
Well, let me see it.
Yep, it's on fire in there. Might have to poke it again. I'm pretty sure all the cells didn't explode. There it goes. Okay.
I think what
It's
this
probably
will,
gonna keep doing this for another 20
I
minutes.
think
to an
this will
hour.
just contain the fire to the bag, but
So we're just
smoke
gonna
is
leave it
gonna
in
find
there,
its way
see how
out.
long the bag lasts.
Vent holes and they're Velcro, like they're purpose.
Well, this one, I mean, yeah, I guess there's still air, but he had to put a hole because he needed to puncture the thing. I mean, that's what I saw him doing. He was like, did you see in the beginning of the video?
I think it's a flap. Yeah, but did he make that flap?
I think he made that flap.
Because he wants to release pressure, otherwise it'll explode. You can just scalpel that.
So yeah, I don't think it's like that much better. It's a little better than nothing, and I think it contains the fire into here.
So
But
yeah, think about it. If you're like on an overhead carry-on and you have your bag, it wouldn't, and your batteries in there compared to that.
yeah. Oh, for sure.
If it can keep oxygen from getting in there, that might help.
Well, no, it's not airtight.
But if you
It's
get a
not.
sealed one, then you just
Yeah.
Get a sandwich bag.
Although, do lithium fires rely on oxygen? Let me think.
it's a chemical reaction, maybe not.
Because you can have fire underwater too, certain types of fire too. Yeah, so that's why I'm thinking like I don't know if just deriving it of oxygen.
We create a lot of rabbit
I
trails
say
in
we
this
get a
one,
bucket.
Actually, this is an important note. If there's lithium fire, don't throw water on it. You're actually gonna make it worse. That's why fire extinguishers. Yeah, fire extinguishers they have A, B, C ratings, and then they have a D rating also, I believe, for lithium fires. And I actually don't know what our fire extinguisher is. What does it say over there? It's right there. It says ABC. It's actually not at the sign. It's on the table, which is, of course. Fire extinguisher letters for lithium. Yeah, it says D. Oh, okay. So I guess an ABC can be used. Okay, I just remember D is what you want.
Does it say anything about halon?
Yeah, so it says like you can use an ABC, but yeah, that should be okay. But I specifically remember put out fire with water is not a good idea.
Not according to Tesla originally. It was on their MSDS safety sheet. They put it out with water.
Yeah, do not use water. Yeah, okay. Yeah, do not use water. Actually, I remember if you put lithium or sodium into water, it's still like it goes crazy. So, yeah. So I guess the bag's better than nothing, but still, I don't know. Like, I don't know how we can, how else we can actually like really contain it.
Once one airline starts doing it, they're gonna.
What's that?
Once one airline does it, it's gonna.
Yeah, I know. There has to be some solution though, because so many things are on lithium-ion battery. You can't like avoid it now.
That's the business we should start. I'll tell you the truth.
Yeah, exactly. Like make something, pitch it to the airlines. That's actually big business right there. There's a lot of auxiliary products you can make. Yeah. All right. The other thing I was gonna show. Oh yeah. So you saw that they mentioned that some batteries have a circuit on top to help control the overcharging, right? Because you can see overcharging basically would also potentially cause a thermal runaway.
This doesn't have that.
This does not.
That's the DJI.
Yeah, and that's why it's important that you set the right settings here, because we don't want any fires here. All right. So, teaching all this, I know it's kind of dry, but it's very important.
Could you go back to the drawing you had?
Yes. What drawing do you like to see? Let me pull it up.
Yeah, understand everything but that anode cathode thing. In chemistry, we learned it one way, but
I know.
even Johnson in electrical engineering, it's like opposite.
What is it again,
Anode
John?
is positive.
Yeah, the diode is the plus is anode,
Yeah.
Okay,
minus is cathode.
Yeah.
Vacuum more.
but the video also said anode is negative. So now I'm like,
The video showed it like that too.
It is the opposite moving. The electron is the opposite.
right. I agree the current's opposite direction, but in terms of,
I mean, the battery and electronic device is the opposite. They are kind of using different way. I think that's why.
okay. I'm also very,
See it on the test and go, oh Jesus.
I won't put that then. I won't put that. Yeah, you can you can like yell at me if I put it on there, and we can change it. But yeah, I know this convention is like super confusing to me because I'm used to like more of the chemistry, and I just remember anode negative ode. That's how I remember it. So that's why I'm like the fact that you're saying it's positive now is like really like throwing me off because all right, anode. Now I gotta look it up because I know we looked at us last time, but now it's like. But the
guy in the video was wrong then. He labeled them wrong.
I swear I seen the anode label as negative somewhere. Maybe it's just in chemistry. Yeah. Okay.
I was saying that, yeah.
See, now it says here is negative. The battery anode is negative.
I went through this hell in undergrad because in chemistry we learned it the way you
Yeah.
learned it. We have a minor in chemistry, but then
Okay.
when we were studying for the MCAT in physics, when you did electricity, it's like,
Yeah.
oh no, it's the other way. I'm like, the fuck do you mean it's the other way?
Yeah.
I learned it one way.
Yeah.
It's the other way now.
Yeah.
Is that because you read the battery, but the flow is opposite?
So yeah, current is going to flow opposite of the flow of electrons because my understanding is the current convention was established before they found out the flow of electrons was actually in one direction. So they said, oh, positive to negative. But really, it's negative to positive. So I know like the electrons are moving, I don't know what the names are anymore, but it's from negative to positive. That's how the electrons are actually moving. But then the current is flowing the opposite direction. At least that's how we display it on like conventionally on paper and stuff like that. Right, John? All right, you're electrical, so that's why I'm not sure I'm not even sure anymore. I'm second guessing myself now. All right. Well, just know that when you're discharging it, meaning you're using the battery, current's flowing one way. You're charging it, you're forcing electrons back where they can accumulate on the negative side, whatever that's called.
Show the drawing again so we got it on a high note, something we understand.
Okay, there we go.
There we go.
There we go. All right. Cool. So back to the slides. Okay, we have different types of plugs here. Look at your drone ahead in front of you. You see they have a yellow plug. Now they don't always turn yellow, but that's the convention here when it comes to XT plugs. So we have from small to big, XT30, that's what we have here on these batteries. You can actually read it if you look closely. It says XT30. Okay. Then we have XT60, that's our standard size that you'll probably find on your typical batteries. Like, for instance, this FPV drone uses an XT60. You see? 30, 60.
Is that always the bouncing plug or no? Is the XT always mean to balance it?
No, we're talking like the main power plug.
Okay.
Yeah, this is the balancing plug.
Oh, I'm
Which
sorry, I got it wrong.
okay, the balancing plug is an JST.
Okay.
JST XH. That's the balancing plug right here.
Okay.
Okay. Now, sometimes you'll find a JST RCY. And I'm just talking main plugs right here. The only plug that's not a main plug but balancing plug is right here, the JST XH. Thankfully, that one's kind of more or less the same, no matter what you use as a main plug. Nowadays, we basically settled on XT. XT30, XT60s are going to be the most common that you're going to see. So it's nice to have an adapter like you see right here. This adapter allows you to go between one or the other. Typically, you have to go from like a 30 to a 60, just like what we have here. If you look here, we have male and female. Self-explanatory here. But you have to look at, this may look like a male, but you have to look at the bullet connectors. That's what actually helps determine whether it's a male. So even though like the casing makes it look like a male, it's really the bullet connector you see is right here. So that's why this is a male and this is a female. This is a male, this is the female. Okay. All of these have mistake proofing. So you can see on the JSTs, we have a rectangle with tapered corners on one end. JST is also a rectangle, but instead of the taper on the short end, it's the taper on the long ends. So the taper is right here and right here. Then we don't really see this too often anymore, but just because this charger up here has it, I want to explain it. It's called a Dean's plug. This is kind of more legacy component, but it has the same concept. So you can see it's in a T shape, so it doesn't allow you to plug it in backwards. We also have on much bigger batteries, you'll see the EC5. Different types of plug, EC3. You can see once again, you see this is the male because it has the bullet connectors on the inside. All right. Any questions on the different types of connectors you see? Okay. Let's see. Why you choose one over the other? Not exactly sure. It's just, I don't know, one company wants to use one over the other. But the size does matter based off the cable size. So when you have a thicker cable, it can handle more current. So that's why you're going to see it proportionally. You're going to see an XT60 on a battery that's bigger and it can handle more current than this one. This battery is considered lower. That's why they put an XT30 on it. Okay. Oh, I wasn't going to show this. Well, I'll talk about it now. Does anyone have figured out why we have one extra balance plug compared to the number of cells? Remember I was saying that?
The batteries are in series on that, and one lead has to be positive while the other 4 are negative?
Not exactly, but somewhat. Along those lines, okay? So basically what happens is each of these wires is connected to each cell, okay? But the cells have 2 ends to it, right? So let's think about this. The first cell, you're going to put it on the positive, and then you're going to put it on the negative, okay? The next cell, you're going to put it on the negative of the previous one and the positive of the next one. And then the next one, you're going to put it on the negative and then the positive. So that's why just on the first cell alone, you already have 2 cables coming out. And then the last cell, you also have 2 cables. Here, let me just show you the image. It might make a little bit more sense here. Okay, so this is a 3-cell battery. 3-cell battery, we're going to just look, the main one is going to look at the first cell, positive, and then the last cell, negative. And you see they're connected in series, so we get the total voltage, because in series you add up the voltages. Now let's look at our balance lead right here. We are plugging in to the positive. That's going to be the port number 4. Then the negative is going to go like this, and that's going to plug here. This green cable is plugging here, which is effectively the same as plugging to here. Do you see that? Because they are bridged. So when you measure between 3 and 4, you are measuring cell number 3. Okay? Now, to measure cell number 2, you need to measure across the positive and negative of that. That's going to be 2 and 3. 2 and 3 is how you measure cell number 2. And then to measure cell number 1 is going to be 2 and 1. So that's why if you look here, there's going to be 1 extra wire for every set of cells that you have. Let's actually measure right here. So our reader told it to us because it's doing that. It's sequentially reading one after another. But we can do it manually using a multimeter. Oh, this one's new. So we can measure it on our own as well. So let's take a look here. I'm going to first just confirm here with our meter. Let's see what we got here. All right, 15.25. Cell is 3.8, 3.8, 3.8. Okay. Oh, and 3.8 because it's 4 cells. All right. Now I'm going to take this multimeter here. What setting do we want to put on here with the multimeter?
Direct voltage.
Yes, which one is that?
That looks like the first one.
First one.
Yeah, it's the first one, the one with the straight lines. And we're doing DC. It's on auto right now, but if I want to, I could press function and force it. Oh, okay, never mind. What's that?
Ranging.
Oh, range. Range should just be the volts. You see how it's changing from volts to millivolts? And it's just changing the decimal point. I think it's just function. It's just going to know that's DC. Okay, let's first check the total voltage. So I'm going to just put it here. And we should get 15.27. That's what we had previously, right? Yeah. Okay. Now, let's do this first cell. I'm going to measure from this point. Oh my goodness. All right. This might be a little tough to do. Let me see. Can you see? Can you see where I held up? Where?
Yeah, we saw it.
Okay, what do you read?
3.81.
3.81. Now let me switch to the next one. 3.81. 3.8. 3.81. What happens if I skip one and I put it right here? What is that going to read?
Nothing. Or double?
It's going to read 2 cells. 7.6. Okay. What if I go to the next one?
3 times.
Yeah, 11.45. And then by going like this, 15.27, I'm effectively reading the entire thing just as if I was putting it right here. Okay. So these access every cell. You can see how that works. Now, I don't know which cell it's accessing, whether it's doing this one or that one. I'm going to guess just based off its position. When I measure these two, it's measuring this cell. But because it kind of goes behind this black cover, so I have no idea. But that's probably most likely what's happening. Oh, yeah, it does. Look. Yeah, I can tell right here. You see this goes here. I can tell from this side. Yeah, so by measuring this red and this black one, I can tell that I'm reading this first cell. So theoretically, you could, like what I could do, although it's a little dangerous because you can see what happens if you mess up with lithium-ion batteries. We have our cells from the battery from last semester. There's like 2 or 3 of them where one cell is dead. The rest are fine. So technically, you can take out that bad cell, take a good one from the other battery, put it in, and restore the battery. You could do that. And actually, if they actually do that on I know on a Prius car, they have the battery, and sometimes it's just one cell that's dead. And instead of swapping the entire battery, because that's what the dealer wants you to do, right? You technically just need to repair maybe one cell, and then the thing is okay again. But you need to find that person that can figure it out and do it for you. But that could save you a lot of money if you're just repairing the one broken cell. Because that's what happened in our case is we had one bad cell that dropped too low. So I'm going to say, we're going to not do that because the consequences of doing it wrong is very bad. So we'll solder other stuff in this class, but you could revive that battery. Okay. Does that make sense, the leads? Okay. You can see what it's doing when you're balance charging is that it's checking and making sure if one cell needs a little bit more voltage, it'll just give it to that one particular cell. And this is what I note right here. I say each battery cell needs to be within 0.05 volts of each other. If we look back at this one, what was the differences we got? Actually, if y'all can take note as I show these, let's see. Let's find out for cell number 1, can you write it down? 3.812. Number 2 is 3.809. Number 3 is 3.810. Number 4 is 3.822. Okay, what's the lowest and the highest?
3.88.
What's the difference between them?
0.012.
0.012. 0.0. Okay, so we're fine. You see it right here? 0.05. Okay, so we're still fine. Now, this thing doesn't show it, and I could bring it next time. I have this charger. Let me show you. I have this charger, the HOTA. It will give you a lot more level of detail. It'll also tell you impedance on the cells. Impedance is basically like resistance, which is not good. Lower number is better. So maybe as a baseline, while we have new batteries, we should plug it in and we should see the impedance because that's only going to go up over time. So we can use that as a baseline. But this will also tell you in a delta V what the difference between the largest and the smallest, just like you did manually here on paper, so that you can monitor it. This charger that we have here is very basic. This is one you can get for like $40. It does the job, but it's not gonna be as fancy. The other one I showed you just now, that can do 2 batteries at once, and it can be different settings. And it also has all these little smart features. It could charge a smartphone, like a wirelessly on top, and all these other fun things.
How much is the HOTA?
HOTA's $120. Now let me show you right here. HOTA H6 Pro. This one right here. Wow. Oh no, this is a different one. I was like, what? Did it drop down in price? Maybe it's not the H1. Which one did I get here? Shoot. Let me just look it up. It's a very popular one right here. Oh, D6, not H1. Yeah, 120. It still stayed the same. So yeah, you can see there's 2 plugs in the front and 2 balance lead. So that way you could do a split screen. You can charge 2 different batteries at once. Now, do keep in mind, like what I was showing you here, your power output is still the same. So if you're charging 2 really large batteries, it may need to reduce the power output to each battery, meaning it's going to be a little slower than if you were to charge 1 battery at a time. But if you're charging 2 batteries that are small enough, like the ones we have here, and the combined amount of power usage on them does not exceed the maximum that we have, then you'll have the benefit of charging both at the same time. You'll be able to charge them twice as fast. But yeah, charging twice is up to the power limit that you have. Again, the batteries that we're dealing with is going to be like well within the limit, so it shouldn't be a problem. Okay, that's this. Battery balance. Internal resistance, I'll have to show you that next time, but that's the impedance that I was talking about. So higher internal resistance means lower performance, more energy is wasted as heat. And there's not a number that I can give you like what we have with cell voltages and current. So that's why while we have a new battery, we should kind of record the impedance, which is going to be shown as ohms because it's like a resistance, and then we can compare over time. So I just have a example here, which is a 1500 milliamp hour battery, just to give you an idea of what type of numbers we might expect. So less than 15 milliohms is new, good, and then over time it builds up, and finally greater than 50 milliohms, it's time to retire. Again, just the baseline. Yeah, take a look at it. And you also want to measure it when the battery has cooled down. Don't do it when it's hot, just like you don't measure your air pressure when it's hot. You want to let it cool down a little bit. So same thing here. We don't want to get a false reading. Okay, we don't have a way to measure this here, so I'm not going to show you. Yeah.
I mean, the battery has not to be running because the current going through the resistor would burn out the meter, wouldn't it?
Wait, I don't understand.
For instance, if there's power to the battery,
yes,
and you're measuring resistance in the battery.
Oh, you can't measure it. Like what it does is this like the other one I was talking about, the HOTA, I think what it does is it runs a little current through it, and then it calculates the resistance off of that. So yeah, you're not supposed to be running it and measure the resistance. Yeah. You have to have some other device that will like basically create a little circuit and then figure out the resistance from it. Okay, this is the charger I recommend. We haven't got it yet, but we do have this other one. Yeah, the Hota D6 Pro. You can see 200 watts. This thing is only 80. So this thing can definitely handle more than twice what we have here. Dual channel, meaning it could do 2 at the same time. It could do all the same functions and a couple more extra fancy features like wireless phone charging USB, $120. So I like it. Also, I like the fact that it has a self-contained brick. This thing. So like, look, there's all this stuff. So I like how it's just one plug, and you plug it in straight to the outlet. That's it. It has the transformer built in, so you don't have to have all this stuff lying around. Okay, this is what it looks like. Okay, I'll show this next time. It'll make more sense when we actually have the device. But we will see the same type of features that we saw last time, right? We'll see the current, we'll see the capacity, charge, duration, the voltage, yeah, and a couple more details. You see temperature, things like that. So, okay, yeah, I'll go over that next. Okay, now, before I move on, the next step we're gonna do is we're gonna actually like start to distribute the boxes so we can build. But before I do that, is there any questions? Any questions so far up to this point? No? Okay. Let's let me look at the last semester's video, or let me just look this up. There is a video on how to assemble this, but since I already did it last year, I think it's a little easier if I explain it live rather than trying to like follow the video and having us go along it. What is this kit called again? Can someone?
Riot FPV.
Rotor Riot.
Riot FPV drone. I can't even find it though.
What's that? Yes, so they're the ones that made this instruction, but I forgot what's the exact frame. Like, is it just?
Is it a 3-inch frame?
I don't know. Does it say on the box or something?
It didn't have a model. Yeah. And then I went on the website and looked for it. I couldn't find it.
Lay Drib Skylight 3-inch ducted DIY.
Oh, that sounds about right. Wait, let me see if I have. Okay, I don't have. What's it called again? Rotor Riot, and then what's that?
Lay Drib, like LEDRIB Skylight.
Skylight.
LITE.
Oh, okay, Ladrib. Okay. Assembly.
It looks like that, but it has flat.
Okay, there was. Yeah, this is it. Okay. No, I don't remember the word Ladrib. Let me look up YouTube here.
But it looks like that box with the. It could just have the same video thing. It looks like the same.
Yeah, let me block this because I think I might have some. I sometimes watch videos on my own personal on this Sensify thing, so I gotta like. It's kind of. It's not the most embarrassing feed, but what is it called? A rotor.
I can see a screen. I'll tell you what.
I know. There it is. Okay, I found it. Okay.
And that you have one of them.
Okay, this is. Let me see. I think this is the video. Oh no. Let me see. Yeah, this is the video. So if you want to look it up, Skylight solder-free build. Yes, this is a solder-free build. I wish it was solder because we did learn that skill. But we can again practice on our own. Speaking of solder, we'll spend the first 30 minutes until 6:30 building, and then the remaining 30 minutes, if you want to, you can play with some solder with flux that I've put over there. Yes, so we could try with that later. Okay, so I'm going to just go over here manually. Did you get it working or somewhat? Okay, we got close. All right, let's take a look here. Let me first kind of just walk it through. Okay. All right. So QuickTime. Ah, darn it! I did it again. Oh my goodness! Don't say. QuickTime. All right. So this is our end drone. I'm looking at the bottom. So let's gather these pieces. There should be a 4-leaf clover type of thing. And then we have 4 arms. Okay. And then we have the body. Okay, we'll put aside this stuff and this one. We'll put that aside for now. So grab this and you can put those over there. Okay, so make sure you grab these components. Do you see that? Okay. And then can you unscrew this one? Let's find out what this one is. Okay, so the ones that we're going to be using, you're going to be using the Hex 2.5 a lot. So I think it's oh, this is not a good kit. Can you grab another kit? Yeah. This kit has like messed up components.
That one done? I think I got it here. If not, I'll grab yours. Yeah.
Okay.
Yeah, it's got one.
Okay. Actually, Chris, yours is a new kit, right? Yours is.
It had, some stuff was open, some stuff was
He just
not.
doesn't want to come up here.
Oh, okay.
I have all the screws though that are in bags.
They're in the original bags.
Yes.
Okay, let's
Well,
take a
there's one
look.
extra one that.
Or maybe it's
No, it's
2.
not 2.
Okay, it might be M2. That might be M2. Okay, so that's
Yeah, there's some that say M2.
right.
and then
Yeah.
you got
Yeah, go ahead and
screws.
unscrew that. Okay, we're about to find out which one you need to use. And for the rest of you, yours have already been open, so
Wow. Should it be that tight?
no. It's probably been Loctited on.
Okay.
Top row, you said.
Top row or the second to the top row?
Well, I think everybody's different.
Okay, yeah.
Yeah.
People should have disassembled it similar, in a similar. Okay, see, people didn't exactly do it in the same. But if you have your screws in the medicine cabinet, it should have been done in a particular order, meaning 1 or 2 should be the first
Yeah,
screws.
these are all. It's,
Does
this one
anyone-
is starting to strip right here? It's was spinning without it spinning, so I stopped.
Okay, does anyone have a kit where they have things in 1 and 2, like the medicine cabinet?
I have 18 to 30. Yeah, 18.
Okay, you know what? Maybe what we did is we worked backwards. So the 18s might be the first few, or no, 30s.
30, then they.
I think the 30s.
The 30 has 6 in it.
Is that gonna be the?
Shoot, let me look at this video.
You want to not even try to get these?
No, don't worry about that.
Okay, and let's just, for now, just give it like a couple turns, salute.
I think it is these ones right here.
Everything
I think
the
it
right
is.
way.
Say 2 or 2.5.
It's 2.
We're trying to. Well, it's a 2 millimeter, but we're trying to figure out which one to use. Well, that's 6. There's 6 in here.
There's 1, 2, 3, 4,
Okay,
5.
let's see. This is the motor screws. You see how there's
There's
a bunch of those. What is this one? There's 4 here, then there's 4 there.
Mm-hmm. And then there's down.
Oh, okay.
here.
Here's the 4 that goes over here.
That's the.
Oh, here's one in the middle too, so that's 5.
But they're not going all the way down. They're just going down to that first stack. Is that what you call it?
Mm-hmm.
You put this thing together and that will get your final exam. Oh, and then
Yeah,
fly
it's
it.
2.
We flew in the soccer field for the
football stadium, or sometimes right
This is it.
that little grassy
Yeah, this
area
is-
by welding, I guess.
Okay, this is it. It's like, okay, I'm gonna hold it upside down.
Usually
Look
at
at it.
night, when
It's gonna be like this, this.
the parking structure
Right.
or is not
Wait, wait a
busy,
second.
we fly in the parking structure.
Okay, so this will be okay.
No?
Yeah, yeah, right? Yeah, you see how we have whole full?
Full.
Mhm.
Okay. So it's
So it goes like this. That looks about right.
Well, as long as they're not
And then the bottom, like,
speeding around the corners, because, you know, they
this
kinda
is the
lean
camera's
the
forward
wrong way
here, so
when you're going up.
oh.
I've got an F-150.
oh, I got it.
Oh yeah, the that goes up.
This goes.
Yeah, it looks like it's got the
Oh, okay. So like this.
yeah, it looks like that.
Wait.
Well, no, because it would be
My
this
2000
way, so it's gonna go
This one would be 6.
on the bottom. It's gonna go underneath. No. Yeah. So like that.
Oh, it goes on top.
Right?
Oh, let me see it. Let me see it.
Because this is the bottom right now, right?
Where's the race? The race is on the inside.
Raise is on the inside, right?
So okay, so I got it. This goes on the bottom.
Okay.
This goes on the bottom. Wait, oh, like this. There you go.
M3 for the first
Cheaper.
Yeah, like this.
Like that. Yep.
I should look at it like this. That's kind of how it's
Those
going.
should be it, and then those go.
This goes
there.
over.
Yep. Yeah.
See?
Right? Yeah.
Yeah, it is. Then
But I
we need to
think
find 5. Can I see? Oh, this one
Of
comes
course,
out.
the one I didn't try that one. I only did
Oh,
4.
let me try. You try all 4. Yeah, that one's straight.
One of them is stripped. Yeah.
Ooh, that's not good. All right, let's try this one. Let's see what this one is.
Oh, that's the wrong one. No, it's not that one.
Nope, this is slightly longer.
Okay.
But I can't guarantee these are all the same length. Maybe it's this one. Oh, I think it's this one. 24. Look, there's 5 in here.
Okay, so that's
Okay.
probably-
Does anyone have box with 5? Let me show you what it looks like.
Box number 5 or?
No, it's not a box with
five,
a.
5 equal.
Okay, you see, it looks like this. This type of screw. It's if you remember, a button head screw. If you look here.
I got 6 screws.
I don't know what the length is. Let me grab a ruler out.
24 is 5.
But it should be a box with 5 of them.
Yeah, 24. That's mine was 24 and a half.
So the number may not line up with ours, but it's 24. 24 is what we have on ours. Let me find out the length. I know not everyone has a ruler, but I mean, this is what it looks like in proportion. This is what it looks like. This type of length. Just to give you an idea. So it's gonna be. It should be about 8 or 6, 7. Wait, let me see. 5, 6, 7, 8, 9.
It's almost
Probably like an. It's probably an 8 millimeter.
9.
8 or 9, yeah, something like
I
that.
have a 9 marked on one of the bags.
Well, that might be your box number. Is that your box number?
No, it says M3 by 9.
Oh, okay.
Yeah,
It might be the by 9.
There's
Do you-
5 of them.
Perfect.
Oh,
That's
there
it.
you go.
M3
Yeah,
by
M3
9. M3 by 9.
Oh, you just ruined the display.
Oh, it's okay. Shoot. I'm gonna write this down
Okay.
because I want to show it on the video. So what is it? M3 by 9 and quantity 5. M3 by 9, quantity 5. Okay, that's what we're dealing with here. Okay. Now we want to lay it out like this. Can you lift up the top plate? Okay. Underneath, first you need to put the clover leaf thing. And this clover leaf is not symmetrically, it's not like the same. It's actually kind of rectangular. So if you look, we're having it go this way. The long way is going to be left and right. Just to show you the difference, this is what it looks like wrong. We want it like this, okay? Or another better way to say it, look at the holes. They should all, the big hole should line up with the little hole. Can you see it? Yeah, the big hole should line up with the little hole left and right of each other. Okay, and then we're going to put the arms so that the holes are also left and right with each other. This is wrong, you see? The holes are now vertical. We want the holes left and right. So line it up like this. Okay. Okay, and then here's the tricky part. we had to insert the screw from the bottom, so I'm just gonna demonstrate the layout. Before we insert that, does everyone get the layout right here? Let me take a photo here just to let's turn on this lamp. Fudge. Let me just turn on. Oh wait, I don't have flash on this thing. Oh, I do have flash on this thing. I'll just turn on flash.
Oh, here. Is this it?
I don't know. Oh, that sounds like it turns on. Is it on now? Oh, I'm gonna take it flash. Screw it. Okay. Alright. Okay, so this is what it should look like on your end. Oh, that's a really bright flash. Let me take it at a slight angle. There you go. That's better. Okay, do you see that? Oh, okay, good, thank you.
It needed to warm up.
Alright, let's get this a little closer. Okay, now the tricky part is we need to insert the bolt from the back end. So now that you have this assembled, let's just do one by one. Put it through the little hole, right?
Yeah. That's where the middle one is.
No, let's do the middle one last. Or, yeah, do the middle one last. Do one of these side holes.
Small hole or big hole?
We're figuring that out now.
Because it goes through the big.
Yeah, it's a small hole.
Small.
Small hole. Yeah, like this. Okay. Do you see? This is the bottom that was touching the red mat. And then we put it through. Okay, so you do that on all four. Go ahead and do it on all four. Maybe what will help is we screw one in. We screw one into this plate, yeah?
You want to?
Yeah.
Okay.
Okay.
Well,
You're gonna,
I almost got it now.
you almost
me
got
try-
it?
let me
Because
try- let me
you're
try
going to be
this.
able to hold all four in?
We'll see.
Okay, alright. Make sure you line up the holes. So we're putting this through the small holes, and then the big holes should also line up. Mm-hmm. Yep. Lift this one up a little, yeah, to get it on. Yes. Okay. It fell
What are you
through.
doing?
Okay,
There we go.
take a look.
And set it down.
Yeah. Okay, you see this? Alright, and then this is the piece that we need. Now you can notice that this has little ridge on one side and not the other side. Can you go ahead and turn it to the other side? No, turn this to the other side.
Oh, you want it?
I just want to show
Oh, I already got it on. Okay, let me take it off.
them. This is the side with ridges. This is the side without. Okay, we want the side with ridges.
Okay.
So this has to go here, and then now you have to like pick the whole thing up, and maybe next time I'll have people assemble it this way. Yeah, there you go.
You have to do it like a car.
I guess, yeah. Maybe don't tighten it all the way yet.
Yeah.
Right now, just do it like loosely. Wait, how come we have?
Because you took one from the kit.
Okay, I was like,
Because
okay,
we-
all right.
Which I think we needed anyways.
Yeah.
It didn't seem like it had it.
Okay,
Now
and
this
then
is
we
missing,
have
so don't forget that.
Yeah, we gotta put that one back. And then we have a fifth screw. So you see, we have 4 screws right here, and then put the 5th one in the middle. Is it not?
It's catching. There it is.
Oh,
Oh, that doesn't seem right.
wait a sec.
You have to jiggle it around a little bit to push it through.
Really?
Yeah.
It is snug. It's
Oh, you know why? Because some of these arms are like.
Okay.
So maybe loosen these a little bit. Here, let's loosen these. Just so they can still swing around a little bit. Yeah. Okay. Yeah. This is why you don't want to You don't want to tighten these all the way because these arms can block the center hole. So make sure that you keep these arms a little loose. That way, when you put in the next, maybe we should have done that one first, but
The middle one?
yeah.
Because, there's
So
there's
now,
a- yeah, now it's way
okay,
easier.
go ahead. Yeah,
it's
go
fine.
ahead.
Okay.
Yeah, it shouldn't be a huge resistance. If it is, then that means one of the arms is blocking.
Should I tighten the other ones back up now?
Before you tighten it up,
You want
you know what? Don't tighten any yet, because we can always access it later.
okay.
So yeah, just keep the whole thing loose. You can put this one back on now.
Doesn't matter. Same screw.
Yeah, it should be okay.
Is that how you do it?
All right, this is what it looks like. So on one side we have that plate, the clover leaf plate. Okay, the other side, and that's the same side that we have the bolt head. The other side we have the main plate with the raised bumps. All right, is that the same here? No? Good.
Bumps on the other side.
Let's see what the next step is. Okay, I know what the next step is. Okay.
That looks right, but I can't.
All right, the next step.
You need to slow down.
Oh, okay. All right, who needs help?
I can help him too.
Yeah, the two of us can go in. Yes. So we actually have a hex driver in your toolkit, but it doesn't have a deep enough pocket for the length of the shaft. So yeah, I'll show you how we're gonna tighten this.
Pliers.
No, we don't want to use pliers on this one, just because it's plastic, so it's gonna eat away. We're just gonna hold it by our hand and just like on the other end, you're gonna use the driver and like tighten it up. That'll be good enough for what we're doing here. Yeah.
How many screws do you have?
So there should be 4 long screws, but 8 nuts.
I only have 2
You only have 2. Which ones?
out of 18.
2, 18. What? Wait, what?
Number 18.
Number 18.
He only has 2 in his box.
Oh, can you check if they're in perhaps one of the other? Okay. All right. Here's what we'll do.
Because I pulled it up.
Yeah. So now you can take
Now
this to the back.
Turn it around. Okay.
Yeah. So you're gonna hold the driver on one side, and then you're going to turn the driver while you hold the nut. Okay, just like that. Holding the nut, turning the driver.
Oh, my fingernails are clean.
They look clean for the photo.
That's pretty tight.
Good.
Now it's starting to spin.
That's fine.
I'm gonna do that too.
Oh, that's a better photo. Yeah.
Was it M2 or M3?
Oh, that's blurry. Right.
The long ones, is it M2
Okay.
or M3?
That's good.
I got it box number 18.
Uh-huh.
That's all I know.
Okay.
You see there, it was the whole box number. Yeah, see, that's
I'll just show this for the screen. Okay, we're gonna come around and check. So who's missing stuff? Are you missing stuff? Oh, we don't need this plate yet. No, we got this plate. Oh, this is the too small one. We need the bigger one. 20. Box number 20.
No, alright. You putting both sets on or just one thing?
Just one set, because the other set is gonna be at the end.
Longer, yeah.
We have to put other components on.
See what it says.
That's right. And then tighten it down by putting the driver on the,
So, I don't
on
need
one
that.
side.
Where am I going?
Just like you see on the
Oh,
screen.
these are going, so the others, these are going in. You can help me, because I've got cut back up now with you guys,
So what you're
so.
gonna do
I'm
is
just starting to put these things in now, so you said.
Does your plastic nuts?
He said
Oh, then
one
there you
eight.
go.
Oh, put that on now, on all four of them?
Yeah, but you only put one set. You're gonna have 4 remaining at the end. Cause we need to put our other components on.
Oh, okay, then the bolt again, or the other nut, the other nut.
Right now, just.
Oh, okay, so
I
you're,
just-
you're
I
putting
just-
these on yet?
No, 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 no.
Okay, I can do that, yeah, okay,
Okay.
thank you.
We good?
So plastic, he said. Just until it drips.
Oh, perfect. So you still have 4 remaining? Okay, good.
Oh, you're right there, okay.
So you'll wanna put a screen.
Alright.
You don't want to be too hard on the nylon.
You might wanna take your top
Chase
plate
the
off,
nylon.
since you're gonna need to. That's why I didn't assemble these yet. So you have your long ones, they'll be 18 remaining.
Mm-hmm. I think so.
Okay, so, yeah, the reason is because, let me show you the example board here. The bumps on this one is supposed to be facing inwards. So you need to basically remove these, yeah. Okay, we can tell people to tighten down those that are actually. if
Not
you-
too tight, though,
Let me, before, you would check around, make sure they have it right, and then they can tighten all these as you see at the moment. Alright, let me see how yours look. You can tighten them all down now. Alright, you can tighten down all your bolts now. You can tighten all yours down now. No, this one needs to be flipped. Right here, because you see how you have a little gap? You see how you have a gap right here? Yeah, because this has a protrusion and that needs to be facing upwards. Yeah, so you need to undo that.
Yeah, I know. I saw it.
No, you need to flip this whole board. Yeah, which means you need to take
You
off
can't
these
enjoy
parts
doing
here.
it.
Yeah.
Oh, is that what this is, enjoyment?
Yeah, I could buy a erector set and,
How do you tighten it?
You just hold the nut. and
hold
you-
the nut and tighten
yeah,
it.
That's it, that's all we need.
Well, my sausage fingers.
No, you're fine, keep going. You don't need to turn the nut, just hold the nut, let it slide down, and then you.
What I'm saying is, once I get it to a point where I can't hold it anymore.
Alright, let's see how well we do. It's okay, it's like,
You dropped something?
So that's about as far as I can get it.
can you hold one edge of the finger to it, even if you can't rock the entire finger? As long as you get somewhere that can. And then I'll check once you're done. Let me see how well, let me see how well you do. I mean, that's basically it, yeah, that's good.
Oh, that's as far as I
Yeah,
can.
you don't need to be like super tight.
Got it.
Yeah, that's fine. Okay, some people are still catching.
What are these for? The little yellow things down there.
Okay, those are spacers. We're about to use those actually.
Those other
We're
ones
about
are
to use that.
Do you need the stack kit or
The what?
electronics or no?
Huh?
Do you need the electronics for it or no?
Yeah.
The-
Oh yeah. So actually, go grab that. Yeah. And the spacers.
They might.
Make sure they're in there.
They're not in my kit.
Oh, I guess we're not doing soldering today. This took longer than I
Yeah,
thought.
I didn't say anything. I was let's do this.
It's okay.
Yeah, I didn't.
They're already
Is
embedded.
there
already
any,
embedded, okay.
Homework for Chris to take to Japan so we can solder?
Chris, are you gone next week?
Yeah.
What type of homework should we taught him?
Oh.
Oh, you want to solder?
Yeah,
No, he doesn't.
Oh, you don't want to solder.
So make him come back with something soldered.
I'm a little Godzilla figure.
What did I talk about today? Oh, batteries. Okay, I'll put some quiz about batteries.
Yeah.
When do you leave, Chris?
Sunday.
Okay, so you have time to do it.
Yeah, I
Yeah.
can do that. But
Okay.
then the next 2 weeks I won't be able to.
Is
do
there-
Okay, that's fine.
Is there a portable solder kit for him to take?
There's that USB thing that you see in your kit. That is a portable soldering kit. It just requires USB.
Problem is, it's considered a weapon, you can't bring it on a plane.
Really?
Soldering iron?
Soldering iron?
Think about it. It's a sharp object.
I know, but you know you could bring a scissor up to 3 inches.
Oh, okay.
Did you know that?
Yes.
Yeah.
Box cutter.
Well, I don't know. That one's different because that one has like an exposed blade. But wait, is that true? You can bring a box cutter?
I've gotten it on so many times and they've never said anything.
I remember once I had this like little keychain that's like a knife
A wallet, right, dude?
and they took those away.
They took that.
I'm
away
like,
from me,
what
but
the
they-
heck?
They didn't
Like,
take away the box.
Oh.
That's so weird, dude. I
was
didn't
like-
say anything. I almost did. I was like, wait, I have.
Yeah.
never mind,
Yeah.
Never mind.
I was like, what? The blade is like an inch.
Yeah.
It was like,
I know exactly.
Yeah.
That's taken away too. And it's a flimsy little blade,
Yeah,
anyways.
I know.
you
I'm
break
like,
it in half.
I could do more damage from like
My hand.
literally, exactly. Or like, yeah, I could take like, I don't know, other stuff. Lithium-ion battery now. Now you know. All right. Did I check yours? Because you had to flip yours, right? Good. You can tighten it all
Did we
down
just
now.
make a ninja star? Is that what this is?
All right. Who else do I need to check? You already checked yours. Yours is good.
We make a ninja star.
Thank you. Make more. We haven't met our daily quota yet.
Jeez.
Yeah.
Who's growling?
That is correct. Just put the rest on. And then you're good to go. You can tighten the rest down.
Okay.
Wait, let me check this one thing.
Sorry, I'm getting ahead. I'm just looking.
That's okay. Let me see. Okay, yeah, those work. You tighten it down. Okay, all right. Who's still working on it? Anyone still working? Okay, we're gonna keep going then. Next, we're going to grab the board. You see this main board here? Now, if you recall from our previous lesson, what are these two components? Can you figure it out?
ESD
Flight control board and electronic speed control.
Mm-hmm. Which one is which?
The big one is the flight control. The small one is
The control board.
the larger one is going to be the control board.
Which one?
Oh.
Tell me which one. Which one is what? What does this plug into?
Battery.
Okay, so what's the first component after the battery?
Control board.
Mm-mm. Look here. What's the first component after? Well,
Control board,
why is there a line
I
here?
got your little thing right here.
Electronic speed controller.
Yes. Okay, there is technically a line that can also go there. It's supposed to be the electronic speed controller. The reason why it is because I gotta go back to camera view. You see, we have some 4 leads coming off. These match up to the motors. Do you see? Look at your motors. Okay, so yeah, it's valid to think that the battery also goes to the controller. I mean the flight control board, but you can see right here, these are going to go to your motors. You can also generally tell this is going to be the ESC because it doesn't really have any fancy like chips on it here. You see, like this type of chip is a more like processing chip. In fact, this is the processing chip. This is if you look at it, ARM, yeah, STM32F. If you look it up, it's going to be some processing board. Okay, and then also this will have a USB port because this is what you plug into your computer to configure it later. Whereas an ESC is generally going to have a bunch of just like simpler chips and larger, like, yeah, you see these are just simpler chips.
So is the ESC always going to be bigger than the flight control?
Generally.
I personally felt
Generally.
how you drew the notes. That's what I went with the flight control board because it was larger. I don't know if
Oh
anybody else
no,
was going
it
off
wasn't.
of
It wasn't. It's not necessarily like
the
meant to
size.
represent the
Okay.
size.
Okay.
In fact, you can see here both of these have. I don't know what's the distance. I think it's
It just logically looks like it's wow.
this has the 20. I think it's a 25 millimeter. Oh, it's a 20 millimeter. It's a 20 millimeter spacing. So you see, both of these have the 20 millimeter spacing because they're meant to be stacked on top of each other. Okay. Other clues. Because we're dealing with solder-less ESC, normal ESC boards would not have these leads. You would just have these pads. Okay, so you should see, here's a grouping of pads, here's a grouping of pads, and it's 3 per motor. So there should be 12, assuming you're using like a normal quadcopter style. If you look here, they're also numbered. 1, 2, 3, 4. So there's different hints to tell you it's an ESC. But generally, the power is going to flow through the ESC first because that's the most power-hungry thing, and then it gets redistributed later. But it could also go straight to the flight control board if it's perhaps a smaller battery. But the battery we're dealing with here, the voltage too high, it can't go straight to the flight control board. It has to get stepped down through the ESC as well. And then this is where the power and signal and all that stuff goes through. Okay, so anyways, what we're going to do is we have to mount this. Because it's a square, you can mount it in one of 4 ways. And I'm just going to use this power plug as a reference point. Okay, we can either mount it. This is the front of the drone, by the way. If you look at it, it looks like a coffin. All right, this is the front of the drone, the head. Okay, so you can either mount it like this with the power plug on the back, on the right,
That's how it was made.
top, or left. Now, if you look farther down the line, this is what the drone looks like. We have a plate that will have to go on top. That already rules out 2 of the orientations. Where's the top plate? Do you have it?
I think it's right there.
Okay. Yeah, so you can see we have a top plate that's going to go here later. So that rules out the top and the bottom orientations. You can only do it from the left or the right. Let me see if it matters.
That's what I was wondering. So it's off to the left, so it would be there.
Let me see if it matters which side we
Yeah,
go.
because the motors, right?
IMU have a direction.
It does, you're right. Okay. So IMU, or internal measurement unit, it does have a direction. If you look here, I found a little yellow arrow. Do you see that?
Yep.
That tells you what forward is.
Ah.
Now, worst case, if you mounted it wrong, you could change it in the software, but let's keep the original settings as intended. So let's mount this in a way that avoids twisting this wire as much as possible. So this is the most ideal mounting. You see a simple loop on the same side. Okay, I'm going to place it here, and then which is better? We can either... Okay, so where's front again? Sorry, I got to find this. This is on the other side.
Only because this, see how this is off to the left, this is
Okay,
so you're right.
So here's my arrow. You see that? The arrow is pointing toward, just to give you a reference. Oh, you know what? We can't do a simple loop, because look, the arrow is pointing toward this ribbon thing, toward the strands. So
front.
this strands has to always face front.
Okay.
So we're gonna have to do kind of a little loop like this. Okay. So I guess we could do it this way. Let me see. This is another approach. Actually, technically, either side is okay
Okay.
because this has to always face
It's
forward.
always facing forward. Okay.
Yeah, but you know what? Just for consistency and also to follow that, let's put our motor wire or the power plug to the right. Okay, remember the coffin? This is the head. Okay, we're gonna put it to the right. Yeah. If your grommets are not there, you need to insert the yellow spacer. You see, we have our little yellow spacers. And that elevates your board from the carbon plate below. That way you're not physically crushing it, the components, and you're not going to potentially short anything out.
Yeah, no, it's gonna be
So the yellow spacers go on before you put the thingy on?
Yes, the yellow spacer needs to be on. For most people, it should already be on because we did this last semester.
Oh, I see.
But this is correct.
Mine came out new.
Oh, yours came out new.
Yeah, they just gave me a bunch of parts.
Okay, so you need to find this
Yeah,
part.
I'm trying
There's
to
your
figure out
cable.
because mine's,
Go ahead
Oh,
and
it's
connect
that
it
good.
to.
mine's, came
So
in
when you put
parts,
the
and
yellow
it's
thing on,
too
you at least go on the board.
simple.
Okay, so this is already on there. So you just need to connect it to here. So when you connect the yellow, okay, let me show it on the board. When you connect the yellow yellow spacers, they need to go in a certain orientation. Okay, if you look here, this is the top. This is the top because it has the power plug coming up. So there's one end of the plug. One of your spacers is thinner. You see, this one's thinner, and then the one that goes on your IMU or flight control board is thicker, and it's not evenly thick. One side is going to be thicker, and then the other side is going to be much thinner. So here's what you do. You need to take first the 4 that are thinner and equal on both sides. You need to put that on the ESC, just like here. Then the one that's thicker, you need to put the thicker side on the bottom. Which side's the bottom? The side that's bottom is the one that has the chip or the opposite side of the USB. The thinner side should be on the USB side, just like you see right here. So does everyone have your silicon spacers? If not, you need to put that on the board first before you mount it onto your stack. Okay? We'll come around and take a look now.
So if it already has the yellow on it, you're good.
Yes.
Okay.
Some people, theirs is brand new, so they have to mount the yellow. But just double check the previous person put the yellow on correctly. Now you can mount. Okay, wait, that's upside down. Yeah, well, it's the same as if you were to mount it.
Okay, so then it's gonna be
How do these spacers come on?
Okay, it's a little tricky. I can maybe help you if it's hard for you to put it in. So the spinner side. Well, it goes in first, but also you want the USB side because I could have mounted it this way. So if you actually have one that doesn't stick out, I just grab one of these little tools. I'm gonna use a blunt too.
Yeah,
Use
nice.
like a sharp tool.
I'm safe.
Minutes, I'm gonna fly it.
Yeah, do it.
I'll throw it if it doesn't work.
Or at least it's
Shove it in.
supposed to extend
Okay.
through. They don't come out.
Okay.
Mine are too short. These are only
We'll probably
18.
end on that
I
note.
thought it was supposed to be 20.
This needs to face the other way because this is
Yours, yours goes all the way. Oh, you haven't got, you don't have yours on
No,
yet.
I don't have mine on there.
Put yours on.
Oh, you're still on this side. Yes. You perfect. So go ahead and put that through here. Okay, if you got to this point, we're gonna just stop and we'll clean up and we'll continue next time.
Yeah, right. That's weird.
But you don't have extended.
You know what? Look at how it's so. Oh, they're the same.
Good. All right. Let me
That's
see
weird.
here.
Well, that one's not even touching right there.
Yeah, but if you push it, you're still not gonna get
Still
to
not
it.
gonna get to it now.
But I think the guy in the video is doing it right. The way I started assembling it, you're like, you gotta flip that all around. I'm like, the guy in the video, I was watching.
Yeah.
I was following his steps and it was.
It was this way, right?
Oh well. Yep. All right. You know we sped up this whole thing because you don't have to solder. You notice the.
It's already.
That's gonna be in your evaluation.
Professor,
Yes.
can I just put
Lack
this
of
part on?
solder.
You said the arrow goes forward, so
This is the front. That's right.
like this.
Yeah, but I'm gonna have you flip it this way. This is also still pointing forward.
Just take the box with you to Japan.
Oh,
and
Yeah, a little home.
That way.
and do we put the rest of these on? Is that-
Yeah, you can put that on now if you want. And we can do that next time.
Now we can use the.
I think I-
What's it?
Forward.
Really?
Well, I'm still telling people you need to flip it.
This one and that one.
Because the whole point. Oh, no, I mentioned this. The whole
Maybe it
point of
might
having
have.
this thicker is to
It's-
stand it
okay.
off, yeah, from the bottom.
Then that's why his is wrong. Okay, I'll wait.
Okay.
Chris.
You need help?
You still have to bring that stuff, right?
The truck, it's supposed to hold it.
Past weekend.
There's like a stand up. With those spikes, and then you have like the armored
I'm just putting them on so they don't lose them.
Yeah.
Or leave it. We're
Yeah.
continuing next week where we
Yeah.
left off. Okay, yeah. I'm just gonna.
They already built them out too.
Oh, they did?
So do you.
Okay. This is, if you want, you could put the 4 nuts on. I only show 2 right here.